Welcome to this 11th grade masterclass, where today we unlock the mechanics of the geometric series. Our journey begins with a legend where an intelligent minister demanded a reward so seemingly small that the king carelessly accepted it without a second thought. The minister asked for just 1 grain of rice on the first square of a chessboard. Simple. 2 grains on the second it doubles. 4 grains on the third. 8 on the fourth. For a while the king's guards could physically count them, but by square 64 the demand became impossible. The total rice exceeded 18 quintillion grains, enough to cover the entire country of India a meter deep. The king had failed to meet the demand, and the empire was bankrupt. Let's see the math that caused this collapse. To understand this series, look back at the king's dilemma. Every legend has a starting point. We call the first grain A. In our story, A equals 1. Next, we need the multiplier, the R, or common ratio. Because the minister demanded the rice double every time, our R is 2. Now, notice the logic. To reach the fourth square, we only doubled 3 times. This is why the nth term uses the power n minus 1. The first square has 0 doublings. This gives us our master formula. Let's put this into action for square 10. Our square number n is 10. We take our starting grain, 1, and multiply it by our ratio, 2 raised to the power of 10 minus 1. That simplifies to 2 to the power of 9. On just the 10th square, the king already owed 512 grains. To help the king understand the magnitude of his debt, we must move from specific numbers to a universal mathematical language. Let us define the total sum as S sub n. In our story, A represents the very first grain of rice on the first square. The letter R represents our common ratio, the doubling effect. We write out the series carefully. The first term is A. The second is a times R. The third is a times R squared. We continue this pattern, square by square. Notice the final term is R to the power of n minus 1. This is because on the 64th square, we have only doubled the first grain 63 times. Now, we perform a brilliant maneuver. We create a second version of this entire mountain of rice. We multiply every single term in the sum by the ratio R. Watch the distribution carefully. When R meets A, it becomes a R. When R meets a R, it grows into a R squared. Every single term in the sequence is upgraded to the next power. This shifts our entire series exactly 1 position to the right. Now, look at the 2 equations together. They are mirrors of each other, shifted by 1 step. What happens if we subtract the bottom row from the top? This is where the magic happens. We align the identical terms vertically. The R on top meets the R on the bottom. Since we are subtracting, they cancel each other out completely. They become 0. The R squared terms meet and vanish. The R cubed terms meet and vanish. This chain reaction ripples through the entire center of the equation. Even the second to last terms, a R to the n minus 1, find their match and disappear. Like a row of falling dominoes, the complexity of the series is erased. When the dust settles, only 2 terms have survived this total cancellation. The very first term A from the top row, and the very last term a R to the n from the bottom. We are left with a simple relationship. Sn minus Rsn equals a minus a R to the n. Now, we use the power of factoring. We pull Sn out of the left side. We pull it out of the right side. Finally, to isolate our total sum, we divide both sides by the quantity 1 minus R. There it is, the master formula, a tool that can calculate any geometric growth in seconds. With the master formula in our hands, we can finally solve the king's dilemma. Let's identify our three variables carefully. First, A is the starting amount. On the first square of the chessboard, there is exactly 1 grain of rice. So at equals 1. Next, R is our growth rate. Since the rice doubles on every square, our ratio is 2. Finally, N is the number of steps. A standard chessboard has 64 squares. Now, watch as we substitute these values into the formula. We replace O with 1, R with 2, and N with 64. The equation looks complex, but we will simplify it step by step. Look at the denominator, 1 minus 2. This gives us -1. Now look at the numerator. We have 1 times the quantity 1 minus 2 to the 64th. Since the 1 is a multiplier, it doesn't change the value. So we have 1 minus 2 to the 64th, all divided by -1. When you divide by -1, the signs flip. The -2 to the 64th becomes positive, and the +1 becomes negative. The final result is 2 to the power of 64 minus 1. At first glance, this might look like a manageable number, but it is not. This is 18 quintillion, 446 quadrillion grains. To put this in perspective, if the king harvested every field on earth, it would take him over 2,000 years to collect this much rice. The universe itself is not old enough for a human to count this pile 1 grain at a time. The king's simple promise has created a mountain that could cover the entire planet.